So we are now in the middle of interpreting results. 10 different kind of things that are in the results that you want to really show. Now the one that I showed here is a kind of a comparative analysis, but I'll take the original results and dig deeper into it before we come into this part here. So the first thing is, which regression estimates are significant, statistically significant? That's the first question you want to note down. And I'm going to show you how to get the answer. Now, in order to get which regression estimates are significant, or which variables, independent variables, are useful in determining the dependent variable, you will have to check the p-value. You would have to check the p-value. Now, if that particular thing does not have a p-value, there is something we call stars that you are going to use to determine. But first, let me explain to you how the p-value would work. If you check the p-value, okay, for price of complement, so let's go to the thing and look at the p-value for price of complement. P-value for price of complement. There you go. There's another version of the original one before we put it into the table. Okay. So look at the p-value for the price of complement C. P-value for the price of complement C. Watch it. What is the p-value? The p-value is the last column. It's known as PR into bracket. That's a probability greater than the absolute value of the t. Okay. So when you look at that p-value, you will see what is the number there. Look at the p-value. P-value there. What number is this? 0.00886. So if you are to correct it to 3 decimals, it will be 0.009. 0.009. Okay. Anytime the p-value is less than 5%, it means that the estimate of the variable is significant. And you want to note that down. Anytime the p-value is less than 5%, that is less than 0.05, then the coefficient or the estimate is significant. Now, if it is significant, you will see that R will put some stars, and the number of stars will determine the level of significance, the actual level of significance. And so you will notice that if it is exhibiting, that is 0.1%. 0.1%, by the way, means 0.0, what do you call it? 0.1% means 0.001. Okay, that's 0.1%. And I want you to really get this, because Gabriel, the answer you gave is good, but I want you to get this, that 0.1% is a different thing. So 0.1%, okay, that is 0.001. Okay. 0.201. Sometimes you have to just open your eyes and then watch this thing as well. 0.01. Okay. So that is 0.1%. This is 0.1%. Now 1% is 0.01. That's 1%. Okay. Then 10% is 0.1. So you have to note. Okay. And when it is 0.001, okay, which I said is 0.1%, all right? When it is that 0.1%, what you want to understand is that it simply means that I will give it 3 stars. Let me just give it a different color. So I will give it star, another star, and a 3rd star. That means that it is 0.1%. Okay, when it is that. When it is 1%, I will give it double star. Double star. It means the variable is significant at 1%. Now listen. When it is 5%, that is 0.05. I will give it just 1 star. 1 star. In fact, let me just delete all of these stars and then show a proper one. Okay. So when it is 1%, I will give it star 1, 2, 3. This one 2 stars, then 3 stars, 1 star. But when it is 10%, okay, 10% is an important one. Let me just move it from here. Okay. When it is 10%, or yes, 10%. This was 5%, by the way. When it is 10%, that is 0.1. Oh, sorry, that is 0.1. I will not give it any star. I will give it a dot. I will give it a dot. Okay, a dot, not any star, but a dot. I can't get a dot, so I have to just let it be. I will just give it a dot, and that dot will indicate to you that R is talking about the fact that it is 10%. I'm sure you understand all that we are doing now. So on the basis of this, let's go to our results and check. Price, on what you are seeing here, just based on what you are seeing here, is price significant or is not significant? If it is, tell me at what percent. Type your answer there. Is price significant or is not significant? If it is significant, at what percent? Actually, if you tell me the percentage, then you are already saying that it's significant. Okay. So is price significant or is not significant? If it is significant, at what percent? Perfect answer. Most of you are telling me it's 10%, so that is very good. It means you are getting it. Now, did I see somebody type 1%? Okay. Price cannot be 0.1%. Prince, you are not with us. Okay. Price is, unless what I just did, you weren't following me, you're doing something else. Okay. So price is significant at 10%. Now let's go to the second variable, complement price. Okay, this one, complement price. Is it significant or is it not significant? And if so, at what percent? If it is significant, at what percent? Complement price. Okay, complement price. You got to be memorizing some of these things and understand them easily. Okay, complement price, what percent? Complement price. Somebody is writing. Okay, complement price is 1%. Significant at 1%. Very good. Income. How about income? Income. What would you say about that? Income. Excellent, Gabriel. It is not significant. Okay. Income is not significant. Okay. Income is not significant. You don't need to look at any model. Just mention the significance by looking at the p-value and the stars. Okay. Now let's look at location urban. Loc urban. Is it significant or is not significant? Loc urban. Is it significant or is not significant? Loc urban. The answers I'm seeing here clearly shows that it is not significant. If you ever wrote significant, you are wrong. Okay. Loc urban is not significant. Oku teaching. Is it significant or is not significant? If it is, at what percent? Oku teaching, Oku trading, real Christians, real Muslims. Are they significant or they are not significant? Because they all have similar things. That's why I put them together. All of them are significant. At what percent? Teresa, you are wrong. It's not 10%. It can never be 10%. They are all significant, not at 1%. George, you are wrong. Okay. The rest of you are correct. It is 0.1%. It's significant. You don't say it's significant at 0.1. Roxanne, that's wrong. You rather say significant at 0.1%. Okay, you either say 0.1% or 0.001. So you got to understand how it works here. All right. So that is one thing that you should know. You should always be able to tell the significance of every independent variable. Okay. Now, let's go to the next thing. Let's go to the next thing that you want to look at. The next one is, are the estimates, the coefficient, are they jointly significant? Are they jointly significant? So the one that we did was individually. It was looking at whether they were individually significant. But this one is looking at put together, are they jointly significant? Okay. Don't bring confidence interval into this because it's quite tricky. Okay. So let's go to, are they jointly significant? Now, if you want to determine whether they are jointly significant, you just try and check the F statistic, okay, the p-value for the F statistic. So look down here, you will see the p-value for the F statistic, this one. The p-value for the F statistic. Now, first of all, the F statistic is 329.1 on 8 independent variables and 31 degrees of freedom. The 31 degrees of freedom is the n minus k. The n minus k. Okay. N minus k. And the n is 40. Okay. The k is the number of independent variables. Then you subtract 1 from it because of the intercept. The intercept is not part. Okay. So it becomes n minus k minus 1. And then you see the p-value. Now the p-value is 2.2e minus 16. 2.2e minus 16. What does that mean? What does that mean? I think we said this thing the last time. What it means is that there are 16 zeros before the 2. There are 16 zeros. So 0.15 zeros, then 2. Okay. So whenever you check the p-value for the F statistic, and that is also less than 5%, then it means that the coefficients are jointly significant. So now let me ask you, are the coefficients jointly significant? Are the coefficients jointly significant? And the answer is what? Yes. The coefficients are jointly significant because the p-value is approximately 0. The p-value is 0. And anytime the p-value is 0, then it is the 0.1%. That's what it implies. It implies 0.1%. 0.1%. Okay, so this is a significant thing. This one will tell you the strength of the independent variable. It's one of the measures of the reliability of the model and then the fitness of the model. Okay. It is a statistical measure of the fitness of the model. Okay. But we have the unstatistical measure, okay, non-statistical measure of the fitness of the, which is the R square. We'll come back to that. All right. So the p-value shows that the coefficients are jointly significant. Abdul Karim, you have a question? Let me just pick that and then we can move on.
Hello, Doc.
Yes.
Yeah, in interpreting the result, I want to know which of them comes first. We have to look at the fitness of the model first before we begin to look at the various p-values.
It doesn't matter. It doesn't matter. Anyone can come first.
Yeah, because if the model it appears the model itself is not significant, it's not well fitted. I get the impression that it doesn't warrant us going even to look at the various p-values of the variable.
That is not correct.
Okay.
Yeah. That is why I started by saying that you can start any one first. The fitness of the model, okay, may not. A model might not be jointly significant, but might not be individually significant, but jointly significant. And it doesn't also mean that once you look at the F test and everything is sorted, then it means all is well. Or nothing is sorted, then it means all is not well. Okay. All of them. You see, regression is not about you want to force something to be correct, but you just want to tell what is happening. You are telling a story. So you are just reporting what you are seeing. Okay, you don't force things to be significant. If they are not significant, they are not significant. You just find out a reason why they are not significant. You go beyond the sheet, beyond the surface to find out what is really happening. Maybe there was model misspecification. Maybe there were some measurement errors. Maybe there were assumption violations. Okay, those are the things that you want to check, but we don't force it that it has to be significant. If you've taken care of everything and the thing is not significant, it's not significant. So just go with the ones I'm giving you. There's no systematic way actually of going about it. Okay. Now let's look at the next thing, and I'm just giving you most of the key things that you will need whenever you are making sense of the analysis. Okay. All right, I've explained it. Let's go to the next thing. Interpret the coefficients of price all the way up to religion Muslims. Interpretation is key. In fact, normally you combine the interpretation with whether or not it's significant. I'm going to do one interpretation for you, and then we can now check it. But before I do the interpretation, I want to just talk about one thing before I come and talk about the interpretation. One thing I want to talk about is the fitness of the regression model, which is the R-square. Is a regression model well fit? Is a regression model well fit? Now, to determine the fitness of the regression model, you use the R-square. The R-square is a fraction of the variability in the dependent variable that is explained by the entire regression line. Now, that is a bit statistical, eh? Gotta make sense. Okay, so here's the thing. Every independent variable is trying to explain the behavior of the dependent variable. Price is trying to explain it. Complement price is trying to explain it. All the others are trying to explain it. Now, let's put all of the explanations together. Without a statistical backing, because it's the F test that will give it a statistical backing. So the R-square tells you that if we put all of them together, are they properly explaining the dependent variable? Okay. So the R-square value, the closer it is towards 100%, it means that the explanation of the regression, it means that most of the data are almost seated on the regression line. And again, while that is true, it doesn't mean that every other thing else is also going to be perfect. Okay, it doesn't mean so. So look at the residual, the R square. In the R, it is called multiple R square. Multiple R square. And when you look at our own multiple R square, it is 99%. What does this mean? Who can guess? What does this 99% mean? By the way, there's a difference between the R square and adjusted R square. Okay. The R square normally doesn't punish you or penalize you for including irrelevant variables. You see, in a regression, you only want relevant dependent variables. Okay, relevant dependent variables. Grace, your hand was up. Relevant dependent variables. That's in a regression. Okay, so because you have relevant dependent variable, if you include an irrelevant dependent variable, the R square must come down, but it doesn't come down. It doesn't come down. That's why we need the adjusted R square. Adjusted R square will punish you for including irrelevant variables. So every time you look at the R square and adjusted, you see that adjusted R square is slightly lower than the R square. The least it can be, they are equal. Other than that, the adjusted R square is slow because it's trying to punish you from including irrelevant variables. Gabriel, you have a question?
Doc, it's not a question.
Okay.
I wanted to answer your question on the R square.
Okay, so you lower it until I ask again. Okay.
All right.
So the R square, as we indicated, the R square is telling you the variability. So the 99%, as you can see here, simply means that the entire regression, all the independent variables put together, are explaining 99% of the variation in the quantity demanded of gene beaters. all of the independent variables put together, okay, are explaining 99% of the variability. It means that when you plot this thing in a polyhedral or any Baker surface, all of them are seated or they are all hanging around the fitted line. Okay. So that is it. It tells you that the model is reliable, is fit. And when you go to our model adjustment, okay, this one, you know, the correction, you can see that this model 1 is the one we are trying to explain. And you can see that in the model 1, there is a value for the R square, which is what? 99%. That's why I'm saying that even if you have other models, the R square will tell you which model might be reliable. That is it. The R square sometimes will tell you the model that has to be relied on. And then you use that to make the rest of your analysis. Now, if you look at model 2, even though the R square is 100%, you see price is not significant in model 2. In model 2, price is not significant. In model 1, which is the one we are dealing with, the original model, price is not significant. In model 1, it is not clear there that price is significant. Of course, in the one we had it was, but in here, it's not clear that price is significant. The value that you see is the estimate. The value below the estimate is the standard error. But in model 3, it is significant. It is significant at 5%. You see that in model 3. And of course, model 3 was the gene multi-robust, which was the robust, the one that was dealing. Now, later on, like I said, you come to appreciate this model. We'll dig deeper. It is a way to correct for heteroscedasticity and autocorrelation. One of the assumptions of regression is that we should not have heteroscedasticity, we should have homoscedasticity. And that is it. That's model 3. Okay, that's model 3. And then, of course, you have the other models, all of them hanging in it. But then look at the R square. Okay, the R square is telling you not all models will have an R square. Okay. The other aspect, the AIC, the BIC, and all of that, we'll discuss them as we go on. Okay, so we've been able to make sense of the R square. Now, can we go to the interpretation? Unless there is any question. Okay, if there's any question, fine. Other than that, let's go to interpreting regression models.